But I'd like to invite our next speaker, who's Kumar Venkatachlam from CDC.
Good morning, everybody. And Sarah and Richard, thanks for the invitation to be here. And the speakers, both Dauda and Elizabeth before me, have laid out the foundation of the background of the theme of the symposium. And I think that makes it a little bit easier for me to point out what we have been doing in the Latin America. We had the privilege of working for more than 10 years in the regions with multiple partners. And I'm going to sort of highlight our work historically as well as what we are currently doing in the context. So Latin America is one of the regions. There are many countries identified by WHO as potential targets for elimination, some of them in next 2 to 3 years. So the theme of my talk is going to touch upon 3 different areas that my previous speakers have already talked in the context of drug resistance and understanding the evolutionary patterns of drug-resistant parasites and their spread, and how the population structure helps us to understand, and as well as the migration of parasites. And I'm going to present this in 3 different regions. One is the Guyana Shield. In the Guyana Shield, Suriname is targeted for elimination. The local transmission in Suriname is very few. And then in the context of Pacific coast involving Peru as well as Ecuador and Colombia, and especially in Ecuador, again, is another country that is targeted for elimination in the next 2 years by 2020. And then Haiti, where malaria elimination efforts are already underway. The target date is 2020. So in the Guyana Shield, one of the questions is there a change in susceptibility to artemisinin? I think Aryan is going to talk probably more about the drug resistance, and in the Southeast Asia, where artemisinin resistant as well as the resistance to the combination partner drugs have emerged. And historically, Guyana Shield has a lot of parallels with Southeast Asia, starting from the chloroquine to SP. The resistance to these drugs pretty much simultaneously evolved in both regions. And we thought the history of artemisinin may be different in South America because the history of exposure to artemisinin is quite different because the programs introduced artemisinin combination therapy since 2001 officially. But as some of you have listened yesterday to Lee's talks as well, the story seems to be we are seeing some parallel what historically we have seen with other drugs. So the point is we are seeing some changes in response to susceptibility to artemisinin. Initially, this was really highlighted by therapeutic efficacy studies. I saw Stefan yesterday from Suriname. I don't know if he's here. And Malti and other colleagues found, and again, Suriname is the country in the Guyana Shield that is almost nearing elimination. They have a very, very few cases of local transmission of malaria. And they found in their therapeutic efficacy studies, there were some evidence for delayed parasite clearance that has been published at least in 2 different papers. So that's what triggered some of the, as a part of the network of work in this region, Guyana has also completed or doing periodic artemisinin therapeutic efficacy studies, and it was found out in 2010 using samples from a retrospective study collected in Guyana, there was evidence for 5% of parasite populations with 580 mutations in K13 gene, and that led then PAHO WHO to a follow-up surveillance study that was again presented yesterday in this room, showed that evidence of further expansion of that particular mutation. You can see that, for example, this is the finding that Stella presented and published. So there were 580 Y mutations that were found in this region, and it came from at least 2 different regions of Guyana. And the initial finding was 5% of samples, and also it was shown in that study the genetic background of these 580 mutations indicated they are different from what has been found in Southeast Asia. In other words, it appeared to be a local evolution. So this is being further confirmed now. Again, as a follow-up, 785 samples, out of them about I think 1.7% of samples had that mutation. Interestingly, that distribution varied in different regions. For example, in the region 1, 8.5% prevalence of mutation was reported. And in some regions, it is much lower. Again, the point is the genetic background of these samples are also very similar to what has been found, confirming that that particular haplotype is evolving in this region. And then in the Suriname, in the therapeutic efficacy studies, no K13 mutations were found. So the question is, the frequency, is it too low or something else is happening? And also looking at evolutionarily, from Southeast Asia, they have indicated in addition to PFK13, there are a couple of other genes that are co-evolving. And when we looked at again, the evolutionary patterns, in these regions, they have a different profile. This work, again, has been published by Stella. The details are over there. And since, this is evolving in this region, so there is a focus to really monitor whether these K13 alleles are spreading in the regions, especially in Venezuela, and also as a part of Guyana Shield, the Roraima state of Brazil. So we have the opportunity to collaborate with Dr. Joselli as well as Jaimin, my colleague Naomi in Brazil. She has a poster 1707. There is more detailed description of this work. That surveillance is ongoing. What we have found so far, genotyping 126 samples, there is no evidence that it has appeared in this region. And then I'm going to switch gear and talk about what's happening in the Pacific coast of Latin America. And here again, the malaria elimination efforts early on in 1950s led to severe population bottleneck. And then these populations rebounded again in 1990s. And so the genetic studies that were conducted at the peak of transmission in Peru indicated there were about 5 different clonal lineages of population. And then there was also evidence subsequently as malaria cases were going up, there was also some admixture of those populations of parasites. One thing that became clear from these molecular patterns of not just the population-based markers, but also linking all the genetically, the backgrounds of the drug resistance and different haplotypes, it became quite clear there was 2 distinct patterns. One thing was that there were some population of parasites, at least 3 different populations that were more common to the coastal regions, and there were at least 2 different lineages that was more from the Amazon. And so based on those observations, it was hypothesized that in the coastal populations, probably the clonal populations that were found in Peru, the founding populations were in Colombia. They historically migrated south, And that became later on confirmed by several studies that have been published. And also, this is also a region where I see Dione is sitting here. Her initial observation as a part of WHO HRP2 test evaluation, she actually observed that HRP2 genetic deletions were more common in the Peruvian Amazon, up to 40%. That was subsequently confirmed. And of course, this is a problem that is happening in multiple other locations as well. So this is just to, again, to highlight, Fabian is here. Thanks, Fabian, for sharing this slide. Based on the hypothesis I told you, Fabian has been using to really investigate the different outbreaks that's happening in Ecuador. As I told you, Ecuador is another country very close to elimination, but in the last couple of years, they are seeing more cases. So the question is always, when they find these outbreaks, where are these outbreak source of parasites coming from? Are they locally still there? As Elizabeth was mentioning, they found using serology in some places, there was still local transmission was going on, where the same kind of things are happening. So basically, in some of the outbreaks he found, these were the residual population of parasites in Ecuador, whereas in some of the outbreaks, it's actually probably more connectivity to the Colombian population. Maybe there is linked to some human migration. And again, another interesting parasite line that seems to be spreading in these regions, we call it as a BB1 lineage of parasites. This was earliest detected in 2006. There were just 3 parasites. This was done in collaboration with NAMRO, with David Bacon and other colleagues subsequently. And then, interestingly, this is an interesting parasite line which has a multiple genetic background of resistant markers as well as the deleted HRP2 as well as HRP3. This particular parasite was actually in the Peruvian coast. Malaria has been eliminated since 2005. In 2010, there was an outbreak. What appeared to be an outbreak became a reintroduction because it took more than 18 months to contain that outbreak. So when we looked at, in collaboration with the Ministry of Health, it became obvious the BB1 lineage that was never historically present, and this region was introduced by a military recruit who came to that region. And also the interesting point about that is it's a different vector population in the coast. This parasite quickly adapted. It became very difficult to contain this outbreak. And interestingly, in 2013, the same parasite was introduced in Cusco. For more than 60, 70 years in Cusco, there was no local transmission of falciparum malaria. And also, clearly, it seems to be expanding. And the question is, some of the increased cases of malaria we see in the region, whether this particular strain is contributing is an interesting question to be further tested. So in other words, is there a super transmission potential for some strains? I mean, we hear this story from Southeast Asia again, some points about superbugs. I'm not claiming this is a superbug, but there may be certain parasites which may be more efficient in getting transmitted through different vector populations. So coming to Haiti, this is again an active elimination effort is going on with the support of multiple partners with the financing from the Gates Foundation. And so we are privileged to be part of this investigation. The good thing with Haiti is chloroquine, although it's resistant everywhere else, still in Central American region and including the Caribbean region, it is still working, so which is a positive thing. And so since you cannot do the classical therapeutic efficacy studies because of the low number of cases, we are using molecular surveillance markers as a surrogate to monitor what's happening in terms of the resistant parasites. So in that context, in Haiti, a national surveillance system involving all the 10 departments were set up. It's a facility-based surveillance where people who are diagnosed with malaria using RDT are further tested for the presence of the chloroquine-resistant markers. So I'm going to show the data, summarize quickly in the slide. The work was done by Eric and multiple others. So the good news is we haven't found so far any chloroquine-resistant genotypes, which is a good news. When it comes to the pyrimethylin-resistant markers, there was just one triple mutant parasites, although there were 33% of the parasites with single mutation. This again goes back to the history of malaria control in Haiti. In 1960s, chloroquine pyrimethamine was given as for the massive mass drug administration for several years. So we know that single mutation is also highly adaptive, so that's still remaining. And interestingly, the sulfadoxine resistant profile also indicated there is no triple mutant, except there was one parasite isolate with a single mutant. And then again, this information is consistent with the chloroquine treatment policy, and also it forms a baseline data for monitoring MDA, because now they are using SP as MDA. They already started some MDA work in the southern part of Haiti. So this baseline data will help to monitor when we use the MDA how they are changing. Then simultaneously, we are also, the Haiti team is collaborating with the Harvard group. Already Dauda and Elizabeth has talked about the barcode, so I don't have to explain that any further. So the bottom line is the samples that were collected as a part of drug resistance surveillance are also tested using population-based markers they just described. So the bottom line is there were about 574 monogenic infection samples. So most of them were monogenic, except a very small number. And then when we further looked at, there were 477 samples. They kind of qualified for cluster analysis. You can see most of the samples came from these three sites, Nepes, Grandans, and as well as the south. So there were basically 43 different clusters, but they were highly related, and their proportion varied in different regions, and also these clusters were highly related, which is again not surprising. When we reduce the population size, then you get to that point, as Dauda was also pointing out. And this is just again what it indicates is the relationship between the clusters, each of the color, like in Grandans, in south, yellow color, then it is the green color. You can, the bottom line is they are all interrelated. Interestingly, we found in Nepes, for example, there was one cluster, this indicated by this green was the most dominant one. And so this again forms a baseline, and that helps to investigate further the tracking the parasite movement. And so this slide is to point out the molecular signatures of the Haitian parasites that are in yellow as well as in this light gray. In comparing to the regional populations, they form a unique molecular signatures, which again helps us to track when, in terms of understanding the parasite movement, whether they are locally spreading or coming from elsewhere. So in summary, molecular markers are simply the tools. They are complementary tools along with many other tools in the fight against elimination. They are valuable for multiple purposes: detecting resistant markers, understanding evolutionary patterns of resistance, tracking parasite migration, is there novel strains appearing, deletion of HRP2 or other things. Then one of the limitation is, but if we want to use these tools effectively, there has to be some kind of a database. But we have the limitation of not having such, databases. And long-term data collection is critical if we want to use them effectively. Then the most important point, as Elizabeth pointed out, it's important all these tools are available for the program. So in that context, local capacity building is critical. And a lot of time, this kind of data is with the academic research community, but there is not in every country, just like in Senegal, the program and the academic community works very well. There is always a disconnect. I think we need to encourage everybody to work together, because elimination is a huge undertaking for a country, because we don't have a perfect tool. So in that context, I think a symposium like this can help to bring all the stakeholders together and work together in support of the program's goal. I think with that, I would like to thank everybody. I'm simply a messenger. This is the people who are in these slides who have done most of the work. I apologize if I missed some of my colleagues not on the slides, and also all other partners in Haiti malaria elimination effort, funders, as well as the people. Thank you so much for your attention.